Let's say you work for a confectionery company. You make a very high quality chocolate candy. You know there's a busy season right around the corner, maybe Christmas Day, Valentine's Day, or Easter Day. So you're going to have high demand. You've been using single acceptance sampling plans with great success, but now you're interested in a double acceptance sampling plan because you heard that the average sample number, or ASN, is lower using these types of plans, meaning you can redirect your staff time more towards production. So how would you go about constructing an operating characteristic curve? So let's start with an example. Here we have a sampling plan with a lot size of 2,400. In the first sample, we're going to take 150 samples. The C is 1, the R is 4. What do these terms mean? If one or less of those 150 are non-conforming, then we can accept the lot. If 4 or more of those 150 are non-conforming, then we have to reject the lot. But what happens if we have 2 or 3 non-conforming? In that case, we would sample one more time. In this example, we would sample 200 more units, and if 5 or fewer of the combined total of 350 units were non-conforming, then we could accept the lot. But if 6 or more of the combined 350 total samples were non-conforming, then we would have to reject the entire lot. So in this case, we have two probabilities. So we're going to call it the combined probability, which is the addition of the probability from the first sample to the probability from the second sample. To determine the probabilities of the first sample, we'll repeat what we already learned how to do in a previous lesson. We'll assume various p-values for the percent nonconforming, and then look up probabilities of acceptance using the number nonconforming values. After we multiply each of these columns times 100, we'll use them as the x and y axes in our operating characteristic curve. So the only question here is, how are we going to determine the probabilities for the second sample? And to do this, we have to look up the individual probabilities from the first sample, which could be 2 or 3, and the cumulative probabilities from the second samples, which could be 3 and 2 respectively. Now I just have two words of caution that'll hopefully keep you out of trouble. The first is to watch out when the two sample sizes are different, as they are in this case, because you're going to be using those sample sizes to determine the numbers non-conforming as you look up the probabilities of acceptance. The other word of caution is that you'll be looking at two different probabilities of acceptance. The first is the individual probability of acceptance, which is different from the cumulative probability of acceptance. These individual probabilities of acceptance will be used for the first sample, whereas the cumulative probabilities of acceptance will be used for the second samples. Nonetheless, all that you have to do to construct the OC curve for a double acceptance sampling plan is to first draw the curve for the first sample, and then follow the rules I just described to construct the curve for the combined sample. So that's how you would construct the double acceptance sampling plan if you're working at a confectionery company making high quality chocolate.